Today's lesson is how to cheat with powers of 10. Okay, so in 3rd and 4th grade, you guys learned about using arrays to show a multiplication problem. And some arrays end up being square. So some examples of square arrays would be like, well, 3 times 3. Write this down. If we were to draw 3 times 3 as a 3 by 3 array, it would look like this. This shows 3 on one side times 3 on the other side. And our answer would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And it makes a perfect square. Of course, my magic whiteboard, it's a perfect square. So what we could do is we could rewrite 3 times 3. We could rewrite it as 3 squared. You might have seen that exponent before. That's what that's called. That is called an exponent. That small floating number says that it is 3 times 3. Now, the reason why it's a 2 is because we have 3 times 3. We have 1 3 times another 3. So the 2 means how many times are you multiplying that number by itself. So think about what 4 squared would look like. It would be 4 times 4. Let's draw that. So here's 4 times 4. We have 4 and we see it twice. We've got 4 here and we have 4 here. So that's what that squared means. It does not mean 4 times 2. 4 times 2 wouldn't even have any of this. 4 times 2 would be that. Well, we don't want that. We want 4 times 4. Twice we have 4 by itself. So can there be other exponents besides squares? Why, yes, indeed there can be. So say we had 3 times 3 times 3. A shortcut using exponents, or what math pros would call exponential notation, would be 3 to the 3rd power. That 3rd power showing we see it 1, 2, 3 times. So the 3 is, what number is it? The 3rd power means how many times is it multiplied by itself. So it's not 3 times 3, that's just 9. It's 3 times 3, which is 9, times another 3, which is 27. So when we're talking about the 3rd power, it means we're doing multiple steps. We're multiplying it by itself and then itself again. So what would 3 to the 4th power be? Try to figure that one out. Press pause now. So that means 3 times 3 times 3 times 3. It's 3 times itself 4 times. Okay, well, 3 times 3 is 9. 9 times 3 we found out before is 27. Now I have 27 times 3. That's not friendly. Look what else I could do. You could figure it out that way, and I bet a lot of you did. But remember, you don't have to go left to right. You could go like this. Ding! Same as 9 times 9. I took care of all my 3 times 3s. So 3 to the 4th power is how we might read that, is 81. It's 3 times 3 times 3 times 3 is 81. So that is just a little introduction to exponents right now. Now we're going to be looking at exponents as they relate to powers of 10. Hold on to your hats, everybody. Okay, let's make a table for ourselves. We need to have a table where we have 4 categories, and we can see these categories right here. We've got a category for the expression, a category for what it would sound like in words if we were to say it out loud, a category for what it would look like with an exponent, that little floating number, and a category for what it looks like in just standard regular word form, or number form, standard number form. So let's start with some expressions using 10. Let's start with 10 to the first power. I'm going to use colors on this to keep track of them. I highly recommend that you do as well as you are going through this table. Okay, so an expression. Let's do 10 times 10. That would be our expression, 10 times 10. With words, what we would say would be 10 squared, because it's going to form one of those square arrays when we draw it all out. 10 squared. With an exponent, 10 to the second power. That's another way to say it too. And the regular standard number, well, we need to solve it. Think, if you multiplied 10 times 10 in a square array, what would your answer be?
100.
Good job, Brooke. 100. Okay, let's see if we can find a pattern here. Let's try the next expression. 10 times 10 times 10. I'm switching colors as well. 10 times 10 times 10. Okay. If we were to draw this out, that would mean that we had a cube that was 10 by 10 by 10. Think about how many small cubes would be in that. Wow. Okay, so we would say 10 cubed, or 10 to the third power. And with an exponent, it would have a floating 3, because we have 1, 2, 3 of the 10s. And then what about standard notation? Well, think, if 10 times 10 is 100, and we have still one more 10 to multiply that by, then we've got 100 times 10, and that's how many little blocks would be in this big cube. That would be
1,000.
Yes! 1,000. Start to look for a pattern here. Let's try 10 times 10 times 10 times 10. 4 of them. There it is. Now, there isn't a fancy way that we're going to say this as 5th graders, like squared or cubed, but what we would say is to the power. So 10 to the power of blank, and in this case, 10 to the power of 4, or 10 to the 4th power is how a math pro would say it. 10 to the 4th power. And with the exponent shortcut, we've got a 10, and then think about what the floating number is going to be. I see the 10. 1, 2, 3, 4 times. Therefore, the exponent is a 4. Oh my gosh, what would our standard form be here? That means 10 times 10 times 10 times 10. Well, we could use what we figured out here and then multiply it by another 10. Or we could think 100 times 100. Either way, you're going to get... All right, Brooke, we've got a tough one. Do you notice anything about the zeros?
They're placing one more each time.
Oh, okay. So how many zeros do you think this is going to have?
4.
Yeah, because that's what our exponent tells us. So we should have 4 zeros. 1, 2, 3, 4, and then our digit of value. And then, Brooke, when I put in my comma, what's that number going to end up being?
10,000.
You got it. So much more fun doing with a partner. Okay, at this point, you're probably starting to notice, geez, this takes up like a lot of room. So that's why math pros use these exponents. They're really a shortcut. They're even a shortcut for this. This number, this exponent, basically says what place value we are in. Think about your pink place value chart. Here, we're in the hundreds place. Here, we're in the thousands place. Here, at 10 to the 4th power, we're in the 10,000s place. So what I want you to do is press pause and fill out your charts for 10 to the 5th power and 10 to the 6th power and see where we get in terms of place value. 10 to the 5th power and 10 to the 6th power. Press pause now. Does your chart look something like mine? Hopefully it does. Now you can really see why this exponent can really come in handy. It's nice. It's a nice shortcut. And it basically means that you see it 6 times. 1, 2, 3, 4, 5, 6, which also means, as we cheat with zeros, that there are 6 zeros. So that's what that exponent means. So this is another way of showing place value. Think about your pink place value chart. And these are all of our whole numbers. So we finally got to 1,000,000. 10 to the 6th power, which is 10 times 10 times 10 times 10 times 10 times 10. Whoa, that's a lot to keep track of. But guess what? There's more. So there are other shortcuts too. So instead of writing out a whole big long number, and you will see scientists use this a lot, someone might write out 4 times 10 to the 3rd, or 4 times 10 cubed, instead of writing out the whole long number. Well, don't go deer in headlights on me. Think, okay, I'm going to do the exponent first. Exponents come first. So 10 to the 3rd power. What that means would be 4 times, and I need to do this first, 10 times 10 times 10. Or the shortcut with the pattern that we learned, it means we've got 3 zeros in it. So 10 cubed would be, and you can look at your table as well, 1,000. Our zeros pattern has worked. So now we have 4 times 1,000. Well, hey, we know how to do that. Fast fact, and then place the rest of the zeros on there. So my fast fact then would be 4 times 1 is 4. And how many zeros do I have? 1, 2, 3. 1, 2, 3. Place the comma to show that I know place value. So 4 times 10 to the 3rd is the same as saying 4,000. Now at this point you might be going, well, why wouldn't you just write 4,000? Come on, that's not that hard. Well, let me show you why. Okay, let's try this one. 100 times 10 to the 13th. Think of how many zeros are going to be in this. If we were talking about the number of atoms, microscopic things, that's when scientists are going to want to be able to use this exponential notation. All right, let's take care of this exponent first. 10 to the 13th power. That means there are going to be 13 zeros. Holy cow. All right, write them out and then check your answer with me. Don't forget your commas to show place value. Okay, so 13 zeros. Now, for putting commas in, we could start over here, or we could start over here. We should start here with the ones, tens, hundreds. So, I'll start there, another comma, another comma. Oh my gosh, this is why we use exponents, people. Holy cow. How would we even say that number? Think about those periods that there are. All right, Brooke, walk me through it. What period is this here?
The ones.
And then what about here?
The thousands.
And what about here?
Millions.
Yeah, and then next?
Billions.
And what's here?
Trillions.
Oh my gosh. We're in the trillions, and this number would be 10 trillion. That's why we use exponents, because it's hard to keep track of all these zeros. And think about if you were counting all of the atoms in a finger. Okay, yeah, you're going to need to use exponential notation, but you know what, guys? We're not done, because all this was the 10 to the 13th power. What about the 100? 100 times 10 trillion. Holy cow, we're going to have a lot of zeros here. Well, don't panic. Let's do our fast fact. 1 times 1 is 1. Now, how many zeros do we need to place on the end? Well, we had 13 from here, and we have 2 more here. So that would be a total of 15 zeros. All right, count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, time for commas. 1, 2, 3. There's the ones period. There's the thousands. There's the millions. There's the billions. Here's the trillions, but I'm past that. You know what this is called? Quadrillions. So we have millions, billions, trillions, quadrillions. That's all Greek and Latin for you there. So this would be 1 quadrillion. A quadrillion. No wonder we don't write it all out in standard notation. So another way of writing this original problem, 100 times 10 to the 13th power, well, we found out our answer here. Could we write our answer in shortcut form too? Maybe just 10 to a certain power. Think about how many zeros you have there. How many 10 times 10 times 10 times 10 times 10 times? How many of those do you have? What would the shortcut be? Remember, huh, Brooke? How many zeros are there?
There's 15.
So based on the table that you have in your notes and the pattern that you found, if there are 15 zeros, what would our exponential notation be?
It would be 10 to the 15th power.
You got it. Woo! So another shortcut would be 10 to the 15th power. Wow! That's a big number, and you can see why in science, working with things that are so small, like protons, neutrons, electrons, and atoms and cells, we would want to have this kind of exponential notation. Yay! All right, your task is all going to be the same tonight. I'm going to give you a problem to work on, and I want you to share with your group how you would write this problem as an expression, how you would say it in words, like what power is it, what power of 10, how you would write it as just a regular number with all those zeros and commas, and how you would write it with an exponent. So it's all the things that are on your table in your notes. You need to have all those parts. I'm going to give you the expression, and you need to fill in everything else. Here it is. Okay. Your expression for your task is 10 times 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 10. What would that be in words? Use the word power in there. What would it look like with an exponent, that floating number? And what would it be in standard form with all those zeros and commas? You're going to need to explain this to a partner tomorrow and how you came up with it. You do not have to start with words. You could start with the standard form or the exponent. I want you to choose the way that you think is the most efficient and be able to tell your partner why you started the way that you did and how you solved your problem. That is all about the powers of 10. Dun, dun, dun.